1105, Chapter 6, Section 1, Composite Functions. First of all, composite function is where we take one function and stick it into another function. The notation for composite functions are where you have this f with a little degree symbol g of x, or you have f with the other function that you're substituting in for the f function, g of x. They both are termed f of g of x, f of g of x. Here's what happens. Here's a couple of examples. This is example 1, 2 of them. On page 416, we have f of x equals 2x squared minus 3. G of x equals 4x. Letter A wants us to go f of g of 1. So what I'm going to do is we're looking for f of g. I'm not going to put the 1 in until I get f of g. So I'm going to take, it's telling me to take 4x and put it in for x in f. So that essentially gives me 2 times 4x squared minus 3. See how the 4x takes the place of the x in f. Well, if I square this, I get 16x squared. Multiplied by 2, I get 32x squared minus 3. Now I can put the 1 in. 1 squared is 1 times 32 minus 3 is 29. You've got to remember that whenever you're dealing with a function and you stick a value in for x, that is your x for your ordered pair, when you solve it in a numerical value, or even an algebraic expression, that's your y. So really what we've done is we found what x is equal to as far as y. So we found the ordered pair 129. Second one on there is g of f of 1. So in terms of this one, we're sticking f in g. So think about that. We're taking this 2x squared minus 3, this whole thing, and we're sticking it in place of this x here. So we're taking f, putting it in for x for g. That's where I got 4 times 2x squared minus 3. Distribute. Now I can stick the 1 in there. 1 squared is 1. 8. 8 minus 4 is negative 4. So we get the ordered pair 1, negative 4. Another thing you've got to be able to do is you've got to be able to get the domain of a composite function. So in example 3, page 417, it says find the domain of f of g when f of x is 1 over x plus 2, g of x is 4 over x minus 1. Well, what it's telling us to do is we're going to take g and stick it in this x for f. So the one thing we can't have is we can't have g undefined. And so based on what we've learned before, we can see that g has a denominator. If x were to be 1, then that would make that 0 on the bottom, which would make it undefined. So we know right away that x cannot be 1. Cannot be 1 because if we substitute it in g, it would be a 0 on the bottom, make it undefined, and we couldn't even solve this. So now what we do is we look at f. Well, in terms of f, it's got a denominator 2. It cannot be negative 2. So what we're going to do, because we're sticking g in that x, and we know it can't be negative 2, what we're going to do is we're going to take that 4 over x minus 1 and set it equal to negative 2, because that's what it can't be. All I got to do is multiply the x minus 1 over. I get 4 equals negative 2x plus 2. I'm adding the 2x over here, subtracting the 4 over here. I get 2x equals negative 2. I get x equals negative 1. So thus we found out that if we want to have a composite function of f of g of x, x cannot be 1 or negative 1. Can't be 1 because it would make it g undefined. Can't be negative 1 because once we substituted it in here, it would make this x a negative 2, which would make this undefined. Last question in this section, example 5, page 418, says you have f of x equals 3x minus 4, g of x equals x plus 4 over 3. So show that f of g of x, in other words, sticking g in f, and g of f of x, and taking f and sticking it in g, both equal x. All right, so here's f of g of x. So what it's telling me, I'm going to take this x plus 4 over 3 I'm sticking it in this x for f. What I've done here. Well, I hope you can see right away that the 3's cancel out. So now we got x plus 4 minus 4. Plus 4 minus 4 gives me x. Done. I did them in different colors so you could see the work better. So now we're going to do g of f of x. So now we're going to take this 3x minus 4 and substitute it into the x here. And so that's what I've done here. You can see that we got 3x minus 4 plus 4. The 4's cancel out. We get 3x over 3. We get x. This is an important process coming up later, because this process here is a process by which we prove mathematically that two functions are inverse functions of each other. So make sure you understand this. Being able to stick one function into one, get 1x, reverse it, put the other function into the first one, get 1x. If I do that, then these are inverses of each other. And we'll cover inverses later in another section.